Okay, today we're looking at the compound interest formula. So after trawling your way through all of the step-by-steps for the years last time we looked at compound interest, today we're going to use a formula. It looks a bit hairy, but it's not. It says FV for future value. So the future value of your investment is going to equal the present value of your investment times, open some brackets, 1 plus your interest rate, and we use your interest rate either as a decimal or by putting it over 100. Close your brackets, to the power of n, which is your number of time periods. Now, if your interest rate was in years, your time period would be in years. If your interest rate was in months, then your time would be in months. So that's where you need to keep an eye out for that. Sometimes, or you would have seen it back in year 10, perhaps we wrote it as A equals P brackets 1 plus R to the power of n. And you can work out your interest by using the formula. The interest is your future value minus your present value. So you've got two formulas that you need to be aware of and use for today's work. The first example says, what will be the final value of an investment of $850 after 3 years at 6.5% per annum, compounding annually? So compounding annually, that tells us everything needs to be in years. So that's in years, so we're good to go. So we write our formula down. The future value is the present value times 1 plus R to the power of n. Our present value is $850. 1 plus our interest rate is 6.5 over 100. And to the power of n is 3. We're going to put that in our calculator. We're going to have 850 times bracket 1 plus 6.5 over 100. I'm going to shut my brackets and I'm going to look for my button that says here, I want it to be a power of 3. And that tells me I have 1026 point, it says 7571. We'll put them all down. So it's money. So we're going to have to put a dollar sign in. 1026, and we're going to round this off to 76 cents. Now, I won't mind too much if you get your rounding wrong, as long as you've got all the rest of it right. That will be fine. Now, it says here how much interest will be earned during the 3 years. So the interest is your future value minus your present value. So that's 1026.76. Take away what we started with, 850. Take away 850. And you get 176.76. So that's our first example. Example 10. Carl invests $3,500 for 2 years at 9% per annum, monthly compounding interest to help him save the deposit for a tradesman's truck. How much interest did his investment earn? So our interest is compounding monthly. So we need to turn our years into months. So 2 years, if we times that by 12, because there's 12 months in a year, that will be 24 months. And at 9% per annum, we're going to have to do 9 divided by 12 and get, 0.75% per month. So our future value is our present value times 1 plus R to the power of n. Our present value is 3,500 times 1 plus our interest rate is 0.75 over 100. and n is 24. I'm going to pop that in our calculator. 3500 times 1 plus 0.75 over 100. Shut my brackets to the power of 24, and I end up with $4,187.45. If you have a look on my calculator screen, if you can see it, we round that off. So that's how much the entire investment was. But the question actually says how much interest did he earn. So his interest is the future value minus the present value. So it's 4187.45. Take away. He invested. Can't read my own writing. $3,500. So his interest was $687.45. Example 11 is a bit tricky. We can do it, but it's a bit tricky because it says what present value must be invested at 6% per annum for 5 years so that you get $12,000. So we use our formula. Future value is present value times 1 plus r to the power of n. And we know our future value is going to be 12,000. The present value is what we want to find. And we're going to have 1 plus 6 over 100 power of 5. So we're going to have to use some algebra and tidy things up a bit. So let's leave our 12,000 here, our present value here. Let's put this in our calculator and see what we get. So let's do 1 plus 6 over 100 to the power of 5. Okay, and it gives us 1.000 blah 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 blah. Oh, maybe, hang on. I think perhaps I didn't put my brackets in up here. Brackets. There we go. So that's actually giving us 1.338225. Okay, that's a bit better. So just pretend that was x, or 3x equals 12,000. To get rid of the times by, we're going to divide by this number. I'm going to do it on this side as well. And that will tell us what our present value needs to be. So 12,000 divided by, I'm going to use my answer key, and that will use the answer we had on the screen before. And that tells us 8967.098. So, therefore, you need 8967, let's say 10, to be invested to get the money in the future. This is a little bit difficult. It is expected that you can do these first couple of examples in order to get the correct answer. Don't stress too much about this last one if you find it difficult. Exercise 104.